this morning, according to the program, is Kristina Lygnerud. I don't know if I pronounced your last name correctly, but she's the head of the energy department in the Environmental Research Institute of Switzerland, and she's an assistant professor at the university as well. She's a PhD in the Gothenburg University. And when it comes to residual energies in the subsoil, she coordinates a project that has been published and is quite known for those of us that are involved in this sector. It's a European project for the 2020 horizon that aims to recuperate urban heat from subways, the Green Use Heat project. The presentation of Kristina is the role of low temperature urban waste heat recovery in achieving 2050 goals. And before I pass the floor on to her, I want to thank her for being here with us today. We know that she's very busy. And without any further delay, the floor is yours, Kristina.
Thank you for the nice introduction and for having me here. It was interesting to listen to the previous speakers, and there is a lot of focus on Madrid, of course. And we also have in ReUseHeat a demo in Madrid, which I will not talk about. And it's a hospital, it's the Severo Hoa Hospital, but we can talk about that one another day. I come from Sweden, not Switzerland, and you pronounce it Lygnerud. Okay, so here I am to talk about experiences from the ReUseHeat project, which is a 4-year project on energy efficiency, where we focus on urban waste heat recovery, so low temperature heat sources. And we will address the metro heat recovery most, which is the one that I think is relevant for you. The agenda is that we first will talk a little bit about the vision of an energy efficient city, at least from the perspective of ReUseHeat. We will shortly address what we mean with the urban waste heat. We have computed what the potential should be in Europe, and we also know how much available heat there is in the metro systems in EU 28. Then we go into our metro heat recovery example and our experiences. And then we will conclude with some learnings we have on the policy aspects. First, so we have a vision in ReUseHeat, and it is that in the future, a smart city will be able to harvest the energy that it generates itself just by people living in it and moving around in it. So every day when you go to work, maybe you use the metro, a lot of energy. You use the bathroom, a lot of sewage. You need to go to the hospital or other service buildings, a lot of energy. And to do all of this in a smart way, we need computer power and data centers. And this is our demo sites. We have these 4 demo sites in the project. And how does urban waste heat recovery work? I guess all of you are engineers and you already know that, but maybe for people like me who are economists, this is interesting information. The most efficient way to use this kind of low temperature heat recovery is, of course, a new building with low energy demand, but you can also recover this kind of heat into existing district heating networks through some kind of island network with switches or heat pumps. And what we do in our demonstrators, we have heat pumps in different constellations, boosting the temperature to the desired levels of existing district heating networks. This is what we demonstrate. We have a data center in Germany, in Braunschweig, where we heat up around 20 to 25 degrees heat streams up to 65 degrees. And then we have the hospital in Madrid. Here we recover waste heat from the cooling towers with about 25-35 degrees, and we boost it up to 55 degrees. And then we have recovery from the metro in Berlin with very low temperatures, for example, compared to London that you heard about. And we will recover 8 to 15 degrees. And we will increase it to about 50 degrees and use it in a low temperature system. So what we did early on in the project was to quantify how much urban waste heat do we have in Europe. And those 4 sources that I have mentioned here that we have our demonstrators on, based on them, we find that there is 1.2 etajoule per year that you could recover. And this is a lot of energy and corresponds to more than 10% of the EU's total energy demand for heat and hot water. And as you can see in the little map, we have it all across Europe. Then, if we go into the metro heat recovery example, this is what the subway in Berlin looks like. And we did an analysis when we did these potential studies. We looked at 37 metro cities in Europe, and they were included to find the potential also of the metro volumes of heat. One finding that we had is that the seasonality is pronounced and we have most waste heat in summer. And here you can see how much would come from different systems. And then in terms of volume, we found that there is about 35 petajoules per year available. And large cities where you could make a lot of heat recovery would be Paris, Madrid, and Barcelona with more than 3 petajoules per year. And very dense metro countries would be France with 441 stations or lines, Spain and Germany. And here you have the map. You can see the distribution and the size of the metro systems and their heat potentials in a bar chart and as a map. If we go to our ReUseHeat metro example, we have the example in Berlin. First, we were going to do it in Bucharest, but as a result of many technical problems and a lot of permission difficulties, because in Bucharest, the permission to get waste heat recovery from the tunnel was at the same level of getting permissions to make new electrical cabling, big cables, commissioning of that. So it was really proving to be an impossible quest. So we had to shift our demo site and we shifted it to Berlin. In Berlin, there is a metro with 146 kilometers of double tracks, 145 stations and 10 lines. And the average distance between 2 stations is 0.8 kilometers. What we will do in our demo is to recover air from the metro tunnel into a local low temperature district heating network. So this is different from the Islington case where there was recovery from the ventilation shaft. Here we take it from the tunnel. And we have a big impact in terms of carbon dioxide reduction with the demo because we replace direct electrical heating with heat recovery. And in Berlin, you have one of the biggest district heating systems in Europe, one of the oldest one of the hottest ones. So what we are doing is we make in the project the connection to the low temperature system. It's a district system. And then we also have a connection to the big and hot network. So that operator can take over at any time to integrate the low temperature heat source. And as a result of course, COVID and these replacement of sites, we are a little bit in delay. We were originally going to be online now in October of 2020, but we are foreseeing to go into validation in March next year. So what have we learned to date? We have learned that tunnels are tricky because you need permits for working in the tunnels and you need access to the tunnel and there is a lot of safety staff. So this means that when we will do our implementation, we can only do it in nighttime between 1 and 3, because this is when the Berlin metro is not operating. So it will be night shifts and we will have to have a lot of safety staff with us. So that's a circumstance making it a little bit hindersome. And then we also discovered that for heat pumps to work well, there is a difficulty in tunnels because there is a lot of metal dust from all of the trains braking and accelerating in the tunnels. So we have to make sure that the heat pump is designed in a special way. We also found that it's not always easy to find an end user of the waste heat that is close to the tunnel. We were in the first example in Bucharest, we identified a hotel and we identified this big supermarket. And then in Berlin, we were first pursuing to go with the technical university, but then we found this this district with a low temperature system. So one search that was very long and difficult was to actually find who wants to use this heat. And then we also see that in Berlin, if we can make it there, we can make it anywhere, because a deeper and warmer metro network will make the efficiency, the COP of the heat pump much better. But what we try to do here is to show that it makes sense to recover heat in the metro system. And our station in Berlin, it's also pretty shallow. So if we would have had a situation lower below ground, we would have had higher temperatures. But we want to show if we can do it there, you could do it anywhere. No excuses. Yeah, and then what is the output going to be in terms of the 2050 goal achievement? So what we do is to recover energy that would otherwise have been completely lost. So it's a green solution, and we increase the energy efficiency of the building, replacing then the electrical heating. And another big important thing is to make the owner of the waste heat, the metro operator, the Berlin Verkehrsbetriebe, aware that they have so much heat that they could do something with. And already now discussing with them, they have identified that if it works in this location, they have at least 10 identical locations in the network, and they have hundreds of similar locations across their network. So once you get the metro operator interested and we can show that it's working, then I think that will be very important for crossing the barriers. Yeah, and here we also have made it in such a way that we have the big and hot district heating network being connected to our heat source to make also the conventional district heating operator aware of the low temperature solution and gaining knowledge on how to actually interact with the low temperature heat source. Yes, so that is what we do in terms of metro heat recovery. And the ReUseHeat project, it's also framing a lot of questions that have previously been forgotten. We are like the baby brother of the project Celsius. We talk with Celsius a lot, we feed input to Celsius. And when we wrote this proposal for this project, the Celsius people told us that they could have put more emphasis on identifying contracts and business models and risk analysis and bankability studies. So this is something that we have engaged in. And doing so, we have identified a lot of things also on policy. So we made an article, it has been published, where we made a review of existing policy framework on the EU level. And when you look at them, there is really a number of them addressing energy, but none of them is explicitly talking about waste heat. So there is a big discussion across Europe that you are all aware. What is waste heat? Is it like is it to be seen as a res, or should we have some kind of other perspective and measurement of it? So there is a big question mark how to assess the waste heat. And when you go to policy frameworks on a national level, looking at district heating, we find that only, we made a study of 5 countries, and we find that only in Germany and Denmark, there is explicit regulation linking to the low temperature waste heat recovery. And we don't find anything on the waste heat recovery side. So we conclude that our kind of solution is not really supported by current policy. Okay, so once that has been identified, it's relevant to discuss what is then needed. So we have concluded that our demo sites do not contain a lot of new technology. I mean, heat pumps have been there for a long time, and also district heating networks. But what is new is the kind of system that we built, because the system goes over the old what is called boundary conditions. So all of a sudden, new stakeholders have to interact with each others. And we have identified that we have 5 key stakeholders for this kind of recovery. It's the policymaker, the district heating operator, the owner of waste heat, the final users, and investors. And the real challenge is to facilitate for them to start interacting in new ways. And this is where policy becomes very important. So if we look at these stakeholder groups from the point of view of the policy that we have, then you see if we are striving for carbon neutrality in 2050, the policymakers have already put in place the green arrow of incentivizing renewables in different ways and energy efficiency. And this green arrow trickles down to the district heating operator, an important stakeholder, who then decarbonizes the existing assets and invests in renewables and improves the energy efficiency of its buildings and operations. But then what we see is that the green arrow is not really following all the way to all of the stakeholders that are important. This is why we have red arrows in this picture. For example, if we look to the owner of the waste heat, the owner of the waste heat has a core business, and recovering the waste heat is a sidekick. And you really need incentives in order to generate an interest amongst the owners of the waste heat to do this extra work, because it's going to be a small part of what they do on a daily basis. And there we see that there is no incentive going all the way to support that. And then in terms of final user, the final user must accept the low temperature heat, where it's coming from, that it's a waste heat source, and also possibly demand it. Here we see that there is very low awareness about this kind of solution, and there is really no demand on the market as of yet. So here we need a push in terms of incentives. And then to the right-hand side in this picture, we have put the investor. And the investor, we know, we talk about the Green Deal, we talk about green investments. It's very good. Everybody wants to do it. But we have identified that the investor, they don't always find the really green investments. They don't know the field, they don't know how to assess them, they don't know if waste heat is good or not. Again, we come back to what is waste heat. So we need there, the red arrow indicates that we need further support. Going to the next slide. So what kind of support then is needed? And the things that we find are missing today are written in red. If we start to the left with the policymakers, so what do we need from them? Well, we need to know what is waste heat. Is it a res? Is it something else? And then for the district heating operator level, we need to understand how to use waste heat. Is it something that we should go for? Is it incentivized? Because every time you go for waste heat, you engage in a contract with somebody who owns the waste heat, and you have this added risk that you do not control everything yourself. So there must be some kind of incentive to mitigate the risk. If we go to the owner of the waste heat, as I said, they need some kind of incentives to go beyond the core business. And that would be facilitated by standardized contracts, because what we see now, every time you go into this kind of venture, you have to make the wheel from scratch. That takes a lot of time and effort. And the permit side, you need to have permits that are facilitated to do the kind of urban waste heat recovery that we want to do. For the final end user, we need to create awareness that this is an alternative, and we need their acceptance to pursue this kind of activity. And there must be the support to build a demand from the end user. And then for the investor, we must make sure that green investments become premium investments for them, that it becomes interesting. So that means that maybe for those who are interested in green bonds, they need to understand what kind of investment in the portfolio is really green. And once we have those measurements in place, so the investor can easily find the green investment, well then it's easy to incentivize that kind of investment. Yeah, and that was really it. So thank you for the attention.
Thank you very much, Kristina. I know you're very tight on time. And I know you have to jump into another meeting. You have given us a very clear explanation and a main frame, and we will be following your project. Thank you very much, Kristina.
Thank you.